Possible research area of quantum is actually quantum kernels, right? In the normal classifiers like support vector classifier or support vector regressor, you might eventually see the kernels, right? What kernel does is that it actually gets a distance between two particular elements or features in the higher dimensional user spaces. What happens is the basic idea of a support vector classifier, or say which is using the kernel, is that if you can't separate them into the lower dimension spaces, you just project them into the higher dimension space so that the distance between them actually becomes larger, and then you can directly separate or get the hyperplane that's actually separating those two particular elements of the different classes. Well, that's the basic idea. So what a kernel does is that it actually gets the distance between those two particular elements without actually just projecting them into the higher dimensional feature spaces. So what happens? What's the problem in the classical scenario in this particular case is that it's very computationally intensive to get this particular distance value on the classical computer. So what a quantum kernel does is that it actually does that with the help of qubits, right? It actually gets that particular distance calculated with a less than complexity using this particular qubits, and then you can actually just perform your naive classification using the support vector classifier or regressor.